let's check it out here. We need to know some things about exponents. We've seen these before, but what is a base? This is the base. 5 is the base here. It's what's being raised to a power. So what is the power? It is 3 in this case. So this has a base of 5. And how do we read this? This goes all the way back to chapter 1. This is 5 being raised or to the third power. 5 to the third power. So what we're going to do is spend a lot of time in this section getting to know exponents, really spending some time with them. Let's go ahead and get started on that. So we know what it is. We know we have a base, we have a power. This is also called the exponent. So what does this mean? I want to practice expanding things. So I want to make it bigger. So what does really 2 to the third power mean? Well, it really means what? I'm taking 2/3 and I'm going to times it by 2/3 and then I'm going to times it by 2/3. That's what the exponent is. Just like this is 5 times 5 times 5. You can do it with a fraction. Whatever, the whole thing is being raised to third. So the base in this case is what? The base was 2/3 and the power was 3. Awesome, very good. So we're going to do a lot of expanding. How about here? Can you look at the base of this one? Sure. The base is -2. It's in the parentheses. What's the power? It's the fifth power. If I want to expand this out, it's just going to be -2 times -2 times -2. I hope I have enough room. Times -2 times -2. So we're going to do a lot of repeating, a lot of expanding. Let's get excited. Here we go. Alright, here we go. So now that we kind of expanded, let's go ahead and condense this. So this is an exponent. So we got 4 times 4 times 4 times 4 times 4. What power is this really? Well, let's condense it. Let's make it smaller. We've got 1, 2, 3, 4, 5, 6. This is just like saying 4 to the 6th power. Ooh, that's a rough looking 6. Let's try that. Oh, that looks like there we go. 4 to the 6th power. How about this? What's the base of this? Well, if I multiply by -3, my base will be -3. How many of those do I have? 3 to the third. Rock and roll. Can we do it for fractions? Sure. Just make sure the whole thing is in parentheses. This is all of 2/5. How many times do I see 2/5 being multiplied? 1, 2, 3, 4, 5. I love condensing. So much faster to condense. Couple more here. Let's see how we do. Letter D. Can I do it with variables? Sure. I have x. How many x's to the 4th power? Can I do a mix, a little mishta here of numbers and variables? Sure. 5 times 5 is what? 5 squared. And y times y times y times y, I believe there's 5 of those. 5 squared, y to the 5th. If you want to say, hey, I know what 5 squared is, that's 25, I'm cool with that. Either way will be correct. So we're trying to write these using exponents though. So our practice is getting these exponents. So again, this could be 3 times 3 times 3, which is 3 cubed. X, what do we have? 2 of these. And how many y's do we have? We have 4 of them. If you really want to say, hey, I know 3 cubed, 3 times 3 is 9, times 3 is 27. That's definitely okay. And there you go. So condensing is awesome. I like condensing. But unfortunately, we're spending a lot of this time expanding. So we kind of already did this up front. Again, what does 4 cubed really means? It means 4 times 4 times 4. I know that 4 times 4 is 16. Times 4 again is 64. I'm okay with that, but our goal is this expanding because we're going to spend some time developing these rules here. How about this? 2/3 again to the 5th. It'll be 2/3 times 2/3 times 2/3 times 2/3 times 2/3. Awesome. And can we do -3? Sure. -3 times -3 times -3 times -3 times -3. Fantastic. You can multiply all the way up, but I just want to expand it. Can we do it for letters then? Sure. We've got m times m times m times m times m. Awesome. Bust it out here. And then numbers. So the opposite condensing, 3 times 3. And then we have x times x times x times x times x. And a lot of times I don't put the dots in the x's. You know, the 3's I need or else it looks like 33. But with these x's, I'm cool just by saying, oh yeah, I can just put them all out like that. Awesome. So 5 to the 4th, we got 5 times 5 times 5 times 5. And again, I'm not going to put those dots. You can if you want. X, x, y, y, y. Now we're getting to some good stuff here. Because now we're going to need to use that to get some rules here. Alright, so how about this? Can I expand it and then simplify it? So I want to actually write out longhand and then simplify it. So we're going to start with what's called product multiplying. So it means multiply. What happens when I do this? Well, I don't know. 2 squared times 2 to the 5th, since they have the same base, is 2 to some power. Not really sure what that is. So let's expand it. What is 2 squared? Aha, it's 2 times 2. What is 2 to the 5th? It is 2 times 2 times 2 times 2 times 2. And what am I doing in the middle? I'm multiplying them. So here's the 2 squared, here's the 2 to the 5th. How many 2's? If I condense that, what do I have? 1, 2, 3, 4, 5, 6, 7. That is 2 to the 7th. Awesome. Pretty cool. Again, so I want to multiply these together. I know I have 3/4. Can I expand 3/4 squared? Sure. It's 3/4 times 3/4. So what do I really have here? Well, you have 3 times 3 times 3, which is 3 cubed on top, or you have 4 times 4 times 4. That is also 3 cubed on bottom. If you want to multiply that out, I'm cool with that. That's really 27. 4 cubed is really 64. So feel free to multiply it out, but again, the exponents are okay. Can I expand this one? Sure. Negative 4 squared is negative 4 times negative 4. Then negative 3 squared is negative 4, or I'm sorry, cubed. Negative 4 cubed is this 3 times. And again, that's great. I'm glad we expanded it, but our whole goal was to write it with exponents again. So this is like saying, since the base is always negative 4, I have 1, 2, 3, 4, 5. Excellent. Very good. I like these. Oh, a couple more. I'm glad I like them because we got more. Oh, we got something. Ooh, a little something going on out here. What's going on out here? Oh, it's Mr. Kelly. I'm sorry, it's not. It's Kelly Fuchsius. Ah, just like Confucius. He says, patience is a virtue. Expanding will test your virtue. Yes, it will. It definitely will, because it's going to take some time. Here we go. Y cubed is just y. Y to the 4th is y. You maybe think, why are we doing this? It's going to be important, though. How many y's do I have here? 1, 2, 3. 1, 2, 3, 4. I have 7 y's. So that is the final answer we want to see. Pretty cool. Y to the 3rd times y to the 4th is y to the 7. Excellent. Let's expand this one. So I've got 2xxx times 4xxxx. So what happens when I mush these all together? What is 2 times 4? Sure, that's just 8. How many x's do I have? These 3 and those 4, so I have x to the 7th. So I've got 8x to the 7th. Pretty cool. Pretty cool. And then the last one, I put parentheses here, but it's all multiply. So I'm looking at 3 times 3 times 3 times 3. That's 3 to the 4th. D squared is just dd. You can put parentheses if you want, but I'm just going to put it times 3, and then I've got 4 d's here. Can I mush all this together? I've got 3 times 3 times 3 times 3 times 3. How many 3's do I got there? 3 to the 1, 2, 3, 4, 5. And then d. This is d to the 6th. So really this mess simplifies to 3 to the 5th, d to the 6th. Pretty cool. Awesome. Moving on. So now we're going to look at powers. What happens when you have a power to a power? Oh, this is crazy time, but it happens. Let's expand it. I want to expand it. So first start with, let's square this. Remember, the whole parentheses is being squared, so that means you're multiplying it by itself. So that really means 2 cubed times 2 cubed. But what is 2 cubed? 2 cubed is really 2 times 2 times 2. Times that by this 2 cubed, I've got 2 times 2 times 2. Holy cow, what do I really have here? I've got 2 to the 1, 2, 3, 4, 5, 6th power. So really 2 cubed squared is actually 2 to the 6th power. Pretty cool. Oh my gosh, let's do this one. I've got 5 cubed times 5 cubed times 5 cubed times 5 cubed, because that's what 5 cubed to the 4th means. I'm taking everything in the parentheses, multiplying it by itself 4 times. Now let's expand that. I know 5 cubed is really 5 times 5 times 5. And I've got another 5 cubed here. Holy cow, this is, you're right, Kelly Fuchsius, testing my patience. 5, oh my gosh, times 5 times 5. I'm getting a cramp in my hand trying to write. 5 times, there we go. So this is all times. Holy cow, can we add these up? I've got 3, 6, 9, 12. So all that was just say, oh yeah, that's 5 to the 12th. Woo! Woo! A lot of work on that. How about this one more with variables? Will that freak you out? Hopefully not. Really, we're saying what? This is x to the 4th, and I'm squaring it, so I'm multiplying it by itself. X to the 4th times x to the 4th. Expand that. We've got x, 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 x. Over here we've got x, 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 x. So how many x's do I have total? Add them up, 4, and 4 is 8. Super. Very nice. Very nice. Oh, there's still 2 more of these. Alright. Cube it. So I'm going to cube everything in the parentheses. So when you cube it, it's going to be 2x cubed times 2x cubed times 2x cubed. And now expand it. This is really, x cubed is 2xx. This is 2x, x. This is 2x, x, and I'm multiplying them. So let's multiply this out. What is 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. And then I've got 3, 6, and 9. And I can already hear it. You know, I'm making this video. It's well before school started here, but I can hear it. Do I have to expand it, Mr. Bruss? And I know Mr. Kelly's going to get the same question. Yes, you have to expand it. That's the whole point of this, is to expand it. You may see a shortcut. Good for you, but we're going to expand it. One more of these. Let's do it. So I'm going to cube it. So everything in here gets cubed. So I'm looking at 4 cubed y squared. That's the first one. I'm going to multiply by itself 3 times because it's being cubed. So I've got 4 cubed y squared. And I've got 4 cubed y squared. Now I'm going to expand it. So I'm looking at 4 cubed is really 4 times 4 times 4. Y squared is yy. Then we've got 4 cubed again. And you've got yy. And then we've got 4 cubed again. And then you got yy. I feel like I'm a broken record. All this multiplying, so what do we got here? Help me out here. How many 4s do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is really 4 to the 9th power. How many y's are in there? 2, 4, 6. Add them all up, so condense it. So expand it, we condense it, we simplify it. I love it. There's our final answer. Awesome. One more of these and then we're done. That's it. Quotient means divide. So can we do it with division? Yes, we can. This is a great one. So let's expand it. Again, the goal is to expand it. So 2 to the 4th I know is 2 times 2 times 2 times 2. That's the top. On bottom is just 2 times 2. Does anything simplify here? Yeah, it does. We can cancel. Since it's all multiplication, I can say this 2 cancels this 2. This 2 cancels this 2. What's left? 2 times 2, which is 2 squared, or if you want to say 4, you can say 4. Pretty cool. I like this one. Does it do it here with variables? What can we do with letters? We've got x, 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 x. Is that 5 of them? Over x cubed, so we've got 3 of them. What's going to happen here? Well, he cancels him, he cancels him, he cancels him. What's left here? X squared. Cool. Let's expand another one. What about numbers in variables? So we got 10x, 1, 2, 3, 4, 5, 6, 7. Expand that bad boy. Over 2x, x. What's going on here? So, do they cancel? Well, they cancel a little differently. What is 10 divided by 2? You know, 2 goes into 2 one time. How many times does it go in here? 5 times. So you've really got a fraction, 5 over 1, which is just 5. And then x cancels x, x cancels x. So we've got 5, excuse me, x to the what power? 1, 2, 3, 4, 5. 5x to the 5th. Whew! Finishing strong here. Here we go. So let's take a look at this fraction here. So on top we've got our 3y, y. Why are we doing it? We got 6 of them. Y to the 6. We got 12. Y. Let's cancel them. So again, does this cancel? No, but it reduces. This 3 goes into it one time. How many times does 3 go into 12? 4 times. And now we're looking at, what is that? That is 1/4. You've got 1. These y's cancel. These y's cancel. Cancel. How many y's are left? 1/4 y squared. So you can get a fraction. If you want it back here, if you wanted to write this one as 5 over 1 x to the 5th, that's cool. It's technically true, but 5 over 1 is just 5, so I didn't write that out. Very good. And sometimes the fraction doesn't even reduce. You're just kind of stuck with it. Alright, but now look at this one. I got numbers up here. So this is really 2 times 2 times 2 times 2 times 2, 2 to the 5th. Then you've got x's, and then you've got y's. Y to the 5th. So expand that all out. 2 to the 5th. 2 squared is just 2 times 2. We've got 3 x's, and just, if it's not written, remember there's just a 1 here. Everything's got something, so just leave it alone. It's just that 1 y. Very cool. Now can we cancel? Well, I see some 2's canceling. That's nice. I see some x canceling. Super. And I see a y cancel. So what is left in all this mess? We've got 2 cubed, 2 times 2 times 2. I've got 1x in there, and I've got y to the 4th. So this whole big monster thing here turned into this little thing. If you really want to expand that 2 cubed, you can say 8. I'm cool with that. Either one of those is good to go. Fantastic. All right, I hope that goes well. Hope you don't get a cramp from writing this all out, but it's worth it.